Today is May 11th, 2022. It is a Wednesday, and today my objective is to explore the difference between PDF and CDF, and to do that, I want to start from the beginning with some data that is supposed to be normally distributed. I'm going to try to plot the histogram, and then I'm going to try to plot the density plot, and then from there I'll try to come up with a question, try to solve it, and visualize everything, and really try to explore the difference between CDF and PDF analytically. And we'll see how it goes. It's just a log, so I might make mistakes, I might search things up, because it's just basically a log of what I'm doing. Alright, so I'll start with, I actually kind of searched up a data set already, a normal distribution data. This is what the data looks like. This is on Kaggle. I'll put the link here. This thing is down in the description box below if you ever want to reference to it. So I'll just put the link to the data set over here. Okay, let me bring this down. Okay, so I'm just gonna download it. Oh, you're okay. So hold on one second. Right, so download, and then it should come up here. You want to open it. I think I'm gonna go to my desktop and just pull it out here. Okay, close that. Should be somewhere over here. I think it's this one. Yep. So let me go back over here, and then what I'll do is in Google Collaboratory, you can right click on the little file icon over here, go to upload to session storage, and I'm gonna go where I put the file and kind of search for it over here, and then I'll wait. I'm gonna right click on the colon, copy path, close this, and then I'm going to import pandas as PD, which is a data analytical library. I'm going to create a data frame, and I'm just going to do pd.read CSV. I'm not going to create a data frame. I'm going to read in the data using pandas, and I'm going to set that data equal to a variable called data. So yeah, and then I'm just going to paste what I copied, the path there, and then I'm going to do data.head, and that's going to pop up like the first 5. What now? Quotations, do not forget the quotations. It's going to pop up the first 5 rows of the data. So it should look like this. Okay. So I'm going to start by trying to plot a histogram. So to plot, I'm going to use Seaborn. As SNS, which is a library with pre-written functions, pre-written like visual graphic functions. So I'm going to do SNS dot histogram, hisplot, and then I'll do profit. So I'll do data. So I'll target this column by doing data and using bracket notation, and then put in the name of the column there. And then this is what the histogram looks like. So basically what this is the frequency of each profit. So if there's let's say we have 658, well, how many times does 658 come up? Well, 658 is around somewhere around here. So you can see that it kind of comes up about like 20 times. And just so you can get an idea about the shape of this data, I'm going to go ahead and do another code snippet. I'm going to do data.shape so we can see how many rows and columns there are in this data. So this is frozen currently, as it always does, so we'll just have to wait. Okay, so there's 200 rows and 2 columns. So okay, that's good. Alright, so this is a histogram, so maybe if I want to make it a little bit better, I'm gonna import matplot lib.pyplot as plt, and then I'll do plt.title to give it a maybe you know what? it's actually very interesting because a hisplot, displot is the same thing as density. I'm trying to think. Okay. Profit distribution. First of all, let me actually see what this data set's about. So it's a company ABC profit. So I'm assuming, okay, over here, profit in thousands. If negative, then loss, else it's profit made by company for given year. Interesting. So profit in thousands, so the profit of a company. Okay. Profit distribution. Interesting. I think, profit, and then over here on the left is the count, which is the same thing as frequency. Okay. I think this is good for a normal distribution. Now, these are basically all bars because it's a histplot. So how can we make it into a curve? So I think, I'm not sure if there is a density. So if I do histplot, let me do histplot for now, and then see if I can change it to. Well, it should come up. It's not coming up. Okay. Yeah. But it's not displot. Is there density? I don't think so. Because I think at that point I would have to use norm. Displot, I think, is the old version of hisplot, because displot is a distribution plot. So if I were to just copy this here, put that in there, and run that. Interesting. Okay, so let me kind of research real quick. Displot versus histogram. So you can see the curve, and that's what I wanted, but I thought that the displot was a discontinued version of histogram. I know there's a definite discontinued version of histogram that they said not to use, but I thought that it was displot, or maybe it's just dist. I'm so confused. Maybe in matplotlib. Okay, I think that's the same with but there must be some difference. They all take a single column as input, and the y-axis, blah, blah, blah. Okay. Those putting functions and blah, blah, blah are all helper tools to plot the frequency of a single variable. Depending on the nature of this variable, they might be or more or less suitable for visualization. So a continuous variable x may be histogram to show the frequency distribution, right? A discrete variable, a histogram may or may not be suitable, right? Because if you use NumPy histogram, the bins would need to be exactly in between the expected discrete observations. All right, so histogram. Nope, this didn't help at all. Anyway, comparing a histogram and, well, I can do it myself. I can compare myself. Let's look at. So you can kind of see, well, there is a curve though. Maybe if we had more data, the curve would be more normal. But it looks like a relative normal curve. Does it not? I think it does. I think another way we could do this, actually, but no, I don't know, I'm not sure. Is this not the PDF function? Hold on, I think I can do this in another way. If I import, actually from SciPy, I import stats, and then, what else? Import NumPy. Maybe I'll import NumPy as NP, or probably not. I'll go back to that. And then I already imported Matplotlib, so let me not do that. So then from here, for my x, okay, well, first of all, what are my x values? What are my y values? And then I'll do plt.plot, and I'll do stats. Actually, I'll do x values, y values, and then the y values would be stats.norm.pdf, and it would be your x values, but I don't know what the mean is. But I can easily get that if I just go over here and say data, profit, and I click on mean, okay, and then I can also easily get that if I do data, profit, and I do STD, which stands for standard deviation, And then I think what I'll do is I'll set this equal, but here's the thing though. The way that Python calculates standard deviation is different from the way that we calculate standard deviation. So I think they have the degree of freedom set to 0 or 1. I think they have it set to 1. No, they have it set to 0. Hold on, I did a video about this. I forgot. Wait, hold on. Okay. DDOF minus 1 is to account for any bias. So I think they have it set to 0, because if I do DDOF, well, let's see, right? Let's do 1. Should the answer change? If I do 0, 486. If I delete it, it's 487. So DDOF is set to 0, right? Automatically, because it's 487. No, so it's set to 1. Yeah, it's set to 1 automatically. So yes, I think it's good because it would basically account for a sample. This is sample data. It's not, or is it sample data, or is it data from the entire population? The population would be all profits, or all, I guess, accounts of profits for this company. So do we account for bias, or do we not account for bias for standard deviation? 487, do we do 487 or is it 486? It doesn't make that much of a difference. I think it does though. Do I do -1? Do I not do -1? What do I do? What to do? I mean, hold on. I did a whole session on this. Okay. What do you mean sign in? No. Where do I have it? Variance. See, here it is. No way, I have to log in. No, not now. How do I go to my profile? Did I click on it? Okay. Let's look at my post. Right, so as you can see, when it comes to a sample standard deviation, you do -1, and when it comes to population standard deviation, you do nothing. You do n minus nothing. It's 0. But in pandas, right, because I'm using pandas right now, the standard deviation is set to -1, which is, well, I don't understand. Now that I think of it, in stat class, did we even do -1? I don't think we ever did -1, which didn't make sense to me because we were finding standard deviation of samples the entire time. Yeah, I know. Pandas and NumPy. Complete not sample data set. So a complete data set. I shouldn't have used, well, I didn't know what, this was in the beginning of the year. I should have been like standard deviation of a population data set, not a complete. That's funny. Not sample data set. Way to go, Sarai. In order to get the correct standard deviation, set DDOF equal to 0. By default, it is set to 1, right? I know, but then, okay, if it's a sample, if it's not sample, if it's a complete, if it's from a population, set it to 0. That's what I was thinking, right? But the thing is, how to distinguish between, it's very easy in stat class to distinguish when a data is from a population or from a sample. And if we look over here, I mean, is this a sample or is it, I mean, it's every year, right? But is this a sample of years? Like, it's not really, because they're all in chronological order. So I'm going to treat this, I think, as a population. I don't know. Should I do sample or population? I think I'm going to do this as population. Because if you think about it, mostly in all of these problems, they ask, what is the proportion of blah, 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 below, blah, 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 below a certain point? And that would be things that, I don't know, would it be a sample? I think I'm going to treat it as a population. So if I'm going to treat it as a population, I don't want it to be, I don't want n to be subtracted. I mean, I don't want 1 to be subtracted from n, right? Because that only happens when it's a sample. So I'll set DDOF equal to 0 and use that standard deviation. What? Oh, I put O instead of 0. Okay, so I'll set that equal to my standard deviation, and I'll set this mean equal to my mean. So yeah, it just goes to show you that not everything is, like, you would have to know a little bit of statistics to apply when you're making these things, because there's just little tiny differences. But I'm glad that I took my stat class. I really love that class. Alright, so did I unpause? Yeah. Okay. Where was I? So, my x values, I would usually create my own x values, but because we have data, I think I could just pull straight from the data. So my x values are going to be the profit. And then I'll just put for loc, which is the mean, I'll put mean, my variable. And for my STD, okay, that sounds weird. For my standard deviation, well, it's not standard deviation, sorry, it's scale actually here in norm.pdf. It's going to be my standard deviation. So let me run this, run that, and run that. That is so bad. Okay. Interesting. I mean, it is technically normal, yes. My x values. Did I make this? My x values. So for each of the x values. Oh no. Okay, let me do np dot linspace. No, because then that wouldn't make sense. So maybe I'll start at data profit dot minimum. Is that even something? Is it a function or a method? I don't know. And then I'll end at data profit dot maximum, and then I'll have data profit values in between. I don't know what I'm doing. Let's see. Let's try that. If that turns out to be a mess, then that's not my problem. Just kidding, it is. It's absolutely my problem. Alright, where were we? So this is going to give us an error. This is really annoying. If I do this, well, wait now. Okay, so this is negative 413. Is there any way that I can do min? Can I set it? Isn't it already an integer though? Yeah. Okay, and then I'll just do the same thing. Paste that in there, and I'll just change this to max. Change this to max. And then run that, move it above. Maybe I can change these to min and max. Ugh, so annoying. This is so annoying. What if I just do min and max and it just gives me like the mean? What even was the mean? Negative 500, and then it ends. So you see that it is normally distributed. What if I have 1,000 values? But that's not the data though. And if I have 10, it's gonna be more sharp. But usually it has 200. So if I do 200, but it'll do 200 random ones, right? And I don't want 200 random ones. I want the ones, you know, that are here. So this is interesting. Let's see. It's not even log, mean, and scale. And then if you look at the density, ends at 2,500. That doesn't make sense. How much? Oh my god. Wait. Min max. Oh yeah, 2,000. Yeah, that makes sense. Okay. All right then. I mean, I guess. I just want to double check. Plot normal distribution from pandas data. I just want to double check that I did this correctly. I don't want to do density. I want to do stats.norm. No. How about I do stats.norm.pdf plot pandas data. Maybe it'll be here. Interesting. Mu minus 3, mu plus 3 times sigma. That is interesting. 100 mu 0, which is mean. So this is a standard normal distribution. And so you would do mu. Oh my god, that makes sense, because in a oh my god. Usually you would see, you would plot 3 standard deviations plus and minus the mean. So it would make sense to have, -3 and 3. That makes so much sense. And then you would do x, which is your x values over here. And you would do stats.norm.pdf. And then you would do mean, and then, well, that's not mean. This is mean. This is sigma. And then this is your point. Okay. Page x-axis. Normal. One space, but for me it's not. Right, okay, so maybe I'll do that then. So I feel like this is one version, so let me do like code snippet, put that in there, put this in there. And then put this in there also. And then take this. And then add a form and call this, I don't know, version 1. Alright, so I'm gonna call this version 1, which if I run it should give me, that graph there. But version 2, I think what I'm gonna do instead is kind of what they did. So it's the same thing. Let me just bring that upwards. Alright, okay, where was I? So we're gonna do 3 standard deviations away from the mean. So mean minus 3, and they multiplied by sigma. Interesting. And then mean plus 3 times sigma. Is that what they did specifically? 3 times sigma. So the minimum 3 times. Oh yeah, because it's the third one. Okay, that makes sense. If I do that, it's still going to be kind of, it's more, now you can see that it's more normally distributed than the first one we had. Alright, I think that works, and then, which makes sense because that's how I plotted them manually when I was in stats. Well, I'm still in stats, the year isn't over, but for me it is. And then here's the part where I don't know, I'm not sure, should I put in a certain values from those? Oh my god, wait. If I set the domain, right, which I did, the values are still the values that are going to be within, the values within this domain are still the values that are within this data set or the profit series. Meaning if I put in like 1,000 values in between, it's going to be like 1,000 values of profit, but there aren't 1,000 values, there's 200. So how do I know specifically what to put? Do I put 200 or do I put, because there's not 200 within 3 standard deviations away from the mean, because there's more. And if I do 10, right, like it'll be sharper, it will only calculate the probability density of like 10 of those values. But if I do 200, I mean, it looks really normally distributed. If I do 100, it'll look a little bit, it's like still nice. So I guess we'll do 200 values between there. And the mean, right, if I look at what the mean is and run that, it's about standard, it's about 1,021, and that makes sense because the mean is at the middle, and each profit deviates $486 away from the mean, which makes sense as well. And it makes sense if the mean's at the middle, right? It's normally distributed around the mean. So this is a better version. Version 1. Version 2, which is the better version. And I think over here, did I import Matplotlib? I think I imported it somewhere, so I should have it as the title. So I'll do normal distribution. I should probably have like a post-it note with the symbols of mean and standard deviation. Just gonna have that there. Sigma, so sigma stands for standard deviation. So I'll do that. What is this? No. Where were we? Okay, over here. So I'll just put in, what did we have? So mu of, what do we have? The mu of, actually, I'll do int, oh no, I'll do string round, and then I'll take the mean and I'll round it 4 decimal places, and I'll do sigma, which is over here, of string round, and I'll take the standard deviation and round it to 4 decimal places, and hopefully that works. Yeah, very nice. Only thing is there needs to be a space before the sigma. Okay, so basically what I'm saying is taking the mean, right? Taking the mean, round the mean to 4 decimal places, and make it a string, turn it to a data type string, because right now this is a data type integer, and you can't join strings together. Join different types of data types together in a print, like title or print statement, that are made up of strings, because they're not the same data type, so they have to all be strings. So this is a string, and therefore because I applied the string function around this, it becomes a string, and then I just use, concatenate, is that the word? I don't even know, whatever. Okay, and then I'll do like a plt dot x label, and I'll label it as, what should I label it as? profit, and then I'll do plt.y label, and I'll label it as density. So now if we compare, right, if we go back up here, this right here is a dis plot, while this one over here is a what is it, a density plot. So are they the same? Like, right, so let me copy these things for this one over here, and let me go back over here and kind of just run everything. What do you mean? Okay, well, this is unrelated. Let me just close this. Alright, so now we have this one, right? So what I think I'm gonna do is maybe what I'll do is I'll plot them together so we can compare. I haven't done this in a little while, so I'm not sure if I will remember correctly, but I do have my old code that I can reference to, so that's gonna be good. I'm just gonna import these because sometimes I like to just run certain parts of my code, and if I don't have the import, if I have the imports like someplace like above, it just makes it a little bit harder to do that. So I just like to kind of import things 5,000 times, which is probably bad. Is it bad? Does it take up more storage? I actually don't know. Anyway, I'm gonna do that, and then what I think I'm gonna do once it unfreezes, I'm going to do plt.subplots, and I think that in here you do fig size, you put like a coordinate of 4, 4, and I'm not really sure, it's like a figure and axes type of thing, so if I do axes it gives me the axes, but if I do figure it gives me like a certain thing, right? Okay, alright. If I do delete this, it gives me like a certain figure and axes, right? So figure size, and then with one axis, and axes is a graph. I don't know why they call it axes. That confused me so much when I first started learning this. But yeah. So if I put in 2, whoops. What are the arguments? I kind of forgot. So axes, I don't think that would make sense. Oh, I think what if I do axes 1? Because I didn't do that. Subplots, plt.subplots. Because I need to make 2, right? So plt.subplots. I want to make 2 subplots, and I forgot how to do that. N rows. Oh. I do want 1 row and cols, so I feel like you do n cols, which stands for number of columns, and you do 2, and hopefully that works. And maybe I want to specify n row. You're joking. Is this a joke? Look, I deleted my code. How rude. Oh my god. Okay, I guess we'll have to wait 5,000 hours. Okay, so n cols 2 and rows 1. Okay, that works. But then if I do this and I run it, I see that there are 2 axes. So in order to target those, I think I'm gonna do axes, right? And then axes 2. And then basically what this is doing is, you know how you make, like, you set a variable and you set it equal to like 4, like 3, whatever. Yeah, well, if there's multiple things like 3, 4, 5, then you can do var2, var3, like that's how you, and then if you call var2, then it should give you 4. But not really, probably not. It's just an idea. I don't think this actually works with if I do commas, whatever. It's whatever this returns, you want to do this. Not enough values to unpack. Expected 3, got 2. I don't think there's 3 though. That's weird. Interesting. Maybe we could do fig size 410. Nope. Let's do, wasn't it? Didn't I have it as 510? No, not 510. It had it, I think at 10.5. So first it's the x and then the y. So on the x-axis I want it to be a little larger, obviously. Once it unfreezes, maybe I'll do 10.8. Why is it like that? Yeah, like that. Okay. So here's the problem. I think if I go back up here, I'm going to go to the first one, which is this one. Okay, I'm going to bring that all the way down here. I need to set over here, SNS has an option. Seaborn has an option where we can just set AX equal to a certain axis. So if I do this, what do you mean? Object has no attribute plot. Where did I even have that? What do you mean? Where do I have plot? np.array. What is this thing talking about? Seaborn, matplotlib. Am I going crazy? Like, what is this thing talking about? numpy array object has no attribute plot. Where did I use plot? I didn't use plot here. Was I supposed to use LPOT? No, I don't think so. Seaborn has, right, sns.dis plot. It should have the axes parameter. By the way, parameters are things that go inside the parentheses, or just things that you can change. Ax label. See, ax, see, right there. Should. See, I knew it. I knew it. I told you, did I not tell you? This function is depreciated and will be removed in a future version. Please adapt your code. I told you. I knew this was the one. So which one are we using? Displot? Why did they change this? This doesn't make sense. Okay, displot. And then this one is what? We still have axes, right? Somewhere here. Maybe, maybe not. Oh my god, do we not? I don't see it. Axes. Are you kidding me? This is so annoying. So I guess I'll change it to displot instead. Once it unfreezes. And then I'll go plot and see if it'll still work. Oh my god, that's so ugly. That doesn't make sense. That doesn't make sense at all, because it just doesn't. It's so... What? So what replaces... Nah, bro, I'm so confused. Because it's the same thing. This plot and the histogram are the same thing. But I want... This displot is very... Oh, you know what I can do? I think if I do displot and I do KDE is equal to true, or is it density equals to true? See, I see the curve. So either way, I can visualize the curve no matter if I have that or not. So it's the same thing. It's just, that's interesting. And if I use displot, which was the, does it even have that attribute? False. It does. Interesting. But it says that it's discontinued, or it'll be depreciated. Is that how you say it? Deprecated or depreciated? Why am I so bad at pronunciation? Wow, sir, I couldn't even pronounce that one. Honestly, I'm a little, it's giving lost right now. Like, what's the difference? And, this plot, that's how I had it. So this is how I had it. I think so. I guess that is discontinued. So I guess that's not what we're doing. So then I guess. So really what we're looking at is the histogram and the fact that we could add a KDE is equal to true. If I go over here and do KDE is equal to true, curve line should appear. KDE, I'm pretty sure it's kernel density something. KDE Python. Kernel density estimation, yeah, something like that. Which is so interesting because what in the world is that I don't even know. Because the more bins there are, how do I set the bins if I want 8 bins? 6 bins? If I want 100 bins, the more I do that, the more it fits. Whoa, never mind. It doesn't fit the curve. That's so confusing. Why does it not fit the curve? 50? There's too much, so it would be an underestimation. Interesting. So this is what we're basically looking at, the difference between the hisplot with the curve and then me actually plotting the probability density function. So KDE is a kernel density estimation. Kernel density estimation. So what's the difference between kernel density estimation, KDE, versus just density, or like normal density? Is that, let's refer to, maybe they'll understand what I'm trying to say. Intro to kernel density estimation. Is that what it is? Is the density in the PDF, is that what it is? Is that what it's called, kernel density? Like, is that the real name, or is it two different things? With a normal distribution. Yes, thank you very much. This is what I wanted. I'm trying to compare a kernel density estimate. Literally what I'm trying to do. That's exactly what I'm trying to do. I use the following code to estimate the kernel estimator using blah blah blah, whatever that is. So from skitlearn. So this is if you've never seen it, this is a kind of like a machine learning, deep learning type of linear regression type of stats type of data thing library. It has everything basically. So linspace -5 to 5, num is 1000. Def Silverman BW, whatever TS is, return whatever. Wait, whoa, what is this, man? Kernel density. I don't even know what he wrote. So, okay, the problem is obvious. When I plot these two in the same plot, bless you. When I plot these two in the same plot, it is impossible to compare the two distributions due to different y scales. The red line is the kernel density estimate, but the bluish is a normal distribution. What do I do in order to be able to compare these two? I'm probably missing some scaling standard or something. So are they different? I'm so confused. The plot wouldn't look very different if you compare standard normal distribution with a normal distribution, but that's not what they asked. Wait, is kernel density with standard and normal? Comparing two distributions that have standard deviations differing by a magnitude of over 60 times does not make much sense, even if they do not differ in height of density. Oh my god, what are they saying? I found a solution. Turns out with the guidance from Tim's answer that the norm.pdf function does not work like functions I normally work with in different programming language. I need to scale my variables differently. Do I need to scale my variables differently? Using the function from matplotlib instead, blah blah blah, comparable graphs. Interesting. So it's not the same, is it? It's not the same. Well, obviously here is not the same. Is it from the same data? Kernel density is not an unbiased estimator of the true density, while a normal distribution is an unbiased estimator. Why is kernel density not unbiased? Why is kernel density biased? Okay, wait. So why is kernel density bias? I guess. Let's look at this. Oh, what the heck? Okay, let's read. Density estimation is the problem of reconstructing the probability density function using a set of given data points. Namely, we observe blah blah blah, and we want to recover the underlying probability density function generating our data set. So a classical approach of density estimation is the histogram. Interesting. Density estimation is the histogram. Here we will talk about another approach, the kernel density estimator. The KDE, sometimes called kernel density estimation, is one of the most famous methods for density estimation. Histogram of the faithful data set in R. The blue curve is the density curve estimated by the KDE. So for me, that is this curve right over here somewhere, if I could find it. It's over here. This blue curve right over here. I think I can change the color. No, if I change the color, I'll change the background color. KDE curve color. Are you kidding me? There's a KDE plot? I'm done, bro. Like, this is insane. How do I change the color? Color back? No, but not in a KDE plot, in a his plot. This plot? I don't even know, bro. How do I do that? KDE, reg, fit, his, KDE, whatever. How to change the color? Control F color. Color, map of lib, colors, plot, everything but the fitted curve in. Well, what's the other one? I guess it will change differently. Oh, here it is. Oh, I knew it. It was something like this. I used this before. So, oh, that's what it is. Rug. Wait. I don't think green. That's not what I wanted. I wanted this one. 3 label color, label KDE, his byline with colored green. What? Tell me how this makes sense, because it doesn't. Let me tell you right now. If I go, I don't think it would do anything, honestly. I mean, it'll probably mess up my code. That's what it will do. Okay. Let's see. No, I think this is. Why would it have a label? Is it the legend? Oh, would you look at that? It does work. So, I think it just took. I think KWS stands for basically like Huger. I don't know. It's a weird word. But I just consider it like other parameters that we can use that can be used in other functions, I guess. I don't know. So color, K, I'm assuming K stands for something like black. I don't know what these codes are. Oh, line width is 3, I'm assuming. So if I change that to be 1, I think it will, yeah, okay. So let's change that to 3, and I think color's K. If I do black, would it change anything? It'll still be black. And if I'll do red, it'll be like red, right? And I do, maybe there's a code for red as R. Yeah, so I think I'll just leave it as, I'll leave it as red. So that's clear. And then label KDE. Do we need that label? Do we really need that? Is that mandatory? No, it's not mandatory. So I think this is pretty self-explanatory now that I went through it. So the red, this curve for me, if we go back, this blue curve, actually let me do it blue then, so we can have normality, get it? Like everything the same. Okay, so this curve over here, the blue curve is the same as the blue curve over here, because these are both histograms with, actually, nah bro, I messed up. It's not a histogram, it's this plot. Let me go back up and apply this to my histogram here. So let me collect this and then just go back over here, paste that in there. Are you kidding? Move that in there. Interesting. What if I do, because it doesn't have KDE, how about that? Oh my god, why does this do this to me? It doesn't work. I guess it doesn't have that. His plot. SMS. KDE, KWS. Line KWS. Color. Axes for the color bar. Color palette, color. No, this is not what I want. What if, why does this have to do this? Is there Do I have to do that label KDE here? I don't think so. I don't think that's going to do anything. Whoops, wrote that down in the wrong place. Over here, honey, comma. Yeah, it's not gonna do anything. So it turns out it's only a parameter for a dist plot, which is discontinued, so it doesn't even make sense to do this. If I turn it into a dist plot instead of a dist plot, it doesn't even show up there either. And if I do this a KDE plot, okay, great, that's amazing. And then I guess we're gonna end up with this plot. It's so confusing to me, like what? And then this doesn't work. Is it because it's so weird? Oh, because I don't have KDE. Wait. What now? What do you mean? What now? KDE. It's true. Label KDE. Are you kidding? Change color of KDE on histplot. Python. Oops. Seaborn distribution line. How to change KDE color in seaborn histogram. Yes, please. Color. Blah 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 blah. Color gray parameter both the bars and the kernel blue. Probably histplot doesn't allow to use different colors for the histogram bars and the KDE line. Try to use histplot and KDE plot. So blah 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 SNS. What? What is status? Oh, it's data. SNS histplot. Which is next clear as you work like a charm. Thanks. Really? Really? Where's the thing? So you just add like a. That doesn't make sense. And then I delete this. Are you kidding? Duh, it's not defined. I don't have datos. Are you kidding me right now? It's not that hard. It's really not that hard. If I do black, will it work? Nope, that's amazing, isn't it? If using all scalar values, you must pass an index. Alright, I'm kind of getting annoyed. Search, stack, overflow. Check the data frame. This is not useful. Well, this is definitely not working. What if I try? Oh, it's inside. That doesn't make sense. Maybe if I get rid of KDE is equal to true. I can't do this anymore. Like, what even? And there's no comma. What? There is, it's not inside at all. Like, this doesn't make sense at all. Okay, you know what? I'm not doing this. So I can't even get a proper KDE curve on a his plot. It doesn't even honestly, why am I wasting my time? Like, even if I do KDE is equal to true, I can get the line. I don't need to change the color. I've been wasting so much time. But this is the disk plot with the KDE, which is already like that. Okay, I'm just gonna leave it like this. I don't care enough. But yeah, this curve is the same as this blue curve for the his plot. Alright. Kernel function, smooth symmetric function. Interesting. Oh wow. So each point into, wow. A kernel, and then a kernel, and then density. Interesting. Please. Confidence interval? Get out. I'm not doing that. But can someone tell me why is it biased? Kernel density estimation. Histogram versus KDE's explained. Please, 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 please let this be good. Towards data science articles are always good. Okay. Just for the basic properties of histograms. Scratch understanding of properties. This program first we use for complicated methods. Half an hour a day with some weekend outlier sessions. Sometimes we're tired. Interesting. The probability that a randomly chosen session will last between 25 and 35 minutes can be calculated as the area between the density function and the x-axis and the interval. So when I take a normal distribution and I try to find the proportion of it. I use norm.pdf. Is that calculating the probability? I know it's definitely calculating the area and the proportion, but is that the same as probability? Not really. Yeah, I see that. Oh, okay, so the purpose of KDEs, which is what mentioned in the previous article too, is to estimate the density functions, the PDFs, the probability density functions. That's interesting. Why do we need another function to estimate? Why do we need one function to estimate another function if we could just have that function? I don't understand. Where was I? Ooh, non-parametric statistics. Interesting. Without knowing its distribution, right? Because if I go all the way down here, I never finished this. If I go all the way down here, where is it? I did know its distribution. That doesn't make sense, does it? Oh my god. Oh, you know what I think it's, instead of this is ax.set title. Remove that. There is an attribute set title, excuse you. If I just do, instead of doing this, right, and I just do 1, see how it's there, but it's also not there? Rude. Oh, because I need to make this the figure. I think. You're joking. Oh my god. No, I don't think so. First of all, there is no plot function. What is this thing talking about? Let's see. Let me just open up my, I think it was, did I do this on data science 3 or data science 2? I mean data science 2 or 1? When did I plot multiple functions? I think it was 1, let's see. Alright, I think I'm gonna do control brackets and then wait, do control F. And do subplot. Okay, plt.figure. Oh, yo, I messed up bad. Whoops. See, I knew I didn't remember anything. It's not that I didn't remember anything. I just forgot the notation. You know, it's fine. Everybody makes mistakes. Everybody has those days. I knew I was missing something. So, I'm gonna do, let's do, I had 2 and I had 1, and I forgot what the other parameter was. And then I think we just leave this. Actually, that wouldn't make sense. Figure, is this equal to big? Hold on. Yeah, okay. Yeah, it looked like that. So 9. Wait, but that doesn't make sense. Does it? Right. Okay, over here. What did I do here? Subplots 2, 2. So 2 columns, 2 rows, right? And then this is what I was trying to do. So axes 1.plot. Oh, you would put them in parentheses. That's why. Jesus Christ, I remember this. Okay. I think this is the code that I wanna kind of copy. Yeah. So instead of all of this jazz, I'm just gonna delete everything, put that in there, and then see, I knew it was something. So it was plt.subplots, and with that you can put both the thing and the figure size. Subaxis a little breathing room. Nice. Axis 1.plot. So one row. So n rows and n calls. And this was what, day 134. So reference to day. Okay, I haven't done this since literally last year. Okay, so where are we? Okay, so instead of, oh my god, so I have plotted. So, but I don't want that though. So here's the difference. This is not what I want. I want to go back up here and I want to plot the histogram. If I could just go get it up here, which is this, bring it all the way down and just paste it in there. And then over here, I believe I could do AX is equal to AX1. And then I'll do, and I think it's AX1 set title, or is it dot set title? I think it's dot set title. And then I think that's good, and I don't need this. And then for the second graph, which was this one, I just bring, actually, was it that one? I don't think it was that one. I think it was this one that I was trying to do. I'm gonna put that in there. Instead of PLT, I'll do AX. No. Copy. I want Chinese food. Okay, so AX2 dot set title. AX2 set X label. And then AX2 set Y label. Get rid of that P. And then PLT.plot. And then I think, oh, but this is Matplotlib. Does Matplotlib have an axes thing? Axes 2. Just have that there. And then delete these. Run that. Okay, what now? So the first one did work, but this one, line 2D object, has no property. So how in the world am I supposed to do this? PLT.plot. So Matplotlib doesn't have an axes property? Are you serious? It should have PLT.plot. Oh my god, it doesn't? Really? Okay, so what is the equivalent? PLT.plot in Seaborn. Are you kidding me? I think it's, I don't even know. What is it actually? But Seaborn doesn't do that. I'm so confused. Okay, no. Wrong one. How am I supposed to plot this? Pandas does have, let me see, pandas, functions. Okay, ew. Oh, pandas does have a plot function, so what if, hopefully maybe it has the ax thing. What if I do data.plot? Oh my god, so bad. Oh my god, why does this have to happen? How do I plot this? What if I do SNS? I don't think Seaborn has a plot. Yeah, no, it doesn't. Scatter? That's gonna be really bad. Is it scatter plot or scatter? Okay, that's actually really funny. You can see the individual dots. I mean, it works, but no. KDE plot? I don't think that's gonna do that. I think it's KDE. Nope, never mind. Hist. No, man, I didn't even write that, bro. It's not histogram, it's hist. How do you call it again? SMS dot histplot. Something like that, right? Great. Obviously that's not gonna work. This plot? No. What about this plot? No, the only thing that works is literally the scatter plot, which is not even good. But then if I do the normal plot, what? But it needed to be like a curve. Oh, this is so annoying. How can I assign that to be? Can't I just do plt.plot and do ax2 is equal to that? Oh, it actually did work. What? What do you mean it doesn't have object, no attribute, set title? Oh, because it's not an actual plot, but it did work though, so. And then we could do maybe 8. I think I did 10, 8. No, not, no. I mean 15. I should have done 12. No. Okay, so how to set plt.plot as an axes plot. Maybe I don't want Chinese food. Maybe I want Wingstop. I think I do want Wingstop. Okay, plotting labeled data. Plot? Is plot? Wait, what? Let's see. Is there anywhere where we talk about the... Okay, honey. No. This is so annoying. So what I wanted. The axes PLT. Nah, bro. What are the PLT? And no, I know that. Match all of axes dot plot versus pyplot.plot. Am I going crazy? PLT.plot, PLT.axes. Are you joking? Is this a joke? All I had to do was axes? Why does nobody tell me these things? It's ridiculous. Not me, literally. Maybe I should just like print out all the documentation and just put it on my roof and like watch it. I mean, read it when you watch it. What? Like, honestly, because literally at this point you just have to know documentation or you're clueless. It's like, come on. Okay, move this. Read it from my bed. Like, just like look at it. It's like literally, because at this point, like, what else? Like, it's insane. The things that we have to do to answer one question. Like, why is this so hard? See, but that's what I did. plt.figure axes is equal to figure dot at axes. No, I don't want that. Nah, bro, this is not it. Customize your plots using same line plots, my plot lib, how to set axes range. No, that's not what I mean. How to display a plot in Python using matplotlib. Okay. np.array, get out, I'm not doing that. Subplots. Let's do subplots with axes and plt.plot. Can you just please give me an answer? One can use plt supposed to make all their subplots at once and it returns a figure axes of the subplots as a tuple. Oh my god, I'm learning tuples. Okay, wait, so if it's returning as a tuple, could I? No, never mind. Using plt.subplots, clearing the confusion once and for all. Honestly, literally, because figure and axes will show the difference. Well, the figure is a white background than the axes. The figure is the actual like thing itself, like everything, and the axes is each individual plot within the figure. Understanding usage of PLT figure. No. Can someone just please tell me what to do with PLT.plot? Because in anything in Seaborn, I can just use a parameter called ax and set it equal to the axes, right? But PLT.plot doesn't have that. So what in the world? The only one that gives me something close to what I need is a scatter plot from SNS, I think. Or maybe was it PLT? See? Come on, this is really annoying. Like, maybe I'll do KDE is equal to true. Oh, you're joking me, bro. Oh. PLT.scatter. I mean, I haven't even set it equal to anything. And then it works, but then it also doesn't work. Oh my god. But either way, it doesn't matter. Like, I just wanted to compare the both of them. So on the left, it's a histogram with the KDE is equal to true, but on the right, this is getting the PDF function, right? Which is the probability density function for all of these values. It's a normal distribution. What's the difference between those? That's what I wanted to kind of see. And then at the same time, maybe I should stop here today and then continue this tomorrow because a girl is struggling. Okay, maybe I should search it up. Maybe I should, honestly, I have a Discord, don't I? I haven't gone on Discord since last year. They have like questions. Let's see. Not questions, I mean, I think I was in a math one. I don't think I was in a Python one. I want ice cream. Not ice cream, I don't like ice cream. I mean frozen yogurt. Okay, where am I? Nope, that was last year. Never going back to that again. Oh my god, never mind. I have to go back to that again because I'm going to college and we have to do calc in college. Yay, I forgot about that one. Okay, homework help. Please be Python. Please let there be Python. I don't think there's Python here. Never mind. The late night book club, CG gigs. No, CG is Blender. Castle of Athena. What happened to all of the things that I was in? Studyverse. Oh, I think it was this one. No, that was calc. I think I'm so confused. There was one that I was in that was super useful. Did they change it to Studyverse? No, I don't think so, because there's barely anybody in here. It's not flaggable. What? I was in... Oh, never mind. Well, that's the first time we've gone to Discord this year. Actually, I think I went last... that's a story for another day. Anyway. This is absolutely useless. Okay. Bar, area, hexbin, scatter for scatter plots. Okay, so SNS. So, let me do... SNS.scatter. It's still gonna be the same. Oh, I guess not even. And then for this one, will finally be xx is equal to ax2. Oh my god, Jesus Christ. Yes, you do. You literally. Is it for PLT? Yeah, it is for PLT. Okay, how about SNS? No, Seaborn, I guess, and then look downwards to see other SNS functions. This plot somewhere over here. No, that's not that. One of the following macro functions. axes for between axes dot plot. Maybe it's this one. Oh my god, wait, I think I just saw something that was insane. Did it just say plot? Where is it? Plot empirical cumulative distribution functions? To the CDF function. That's insane. Wait, is that what it does? That's actually really interesting. I'm gonna come back to that. I wanna kinda, okay, I'll watch the video back and see. Okay, axes.plot, but it doesn't have an AX. Oh, this is so irritating. What is the purpose of this? Plot Y versus axis lines or markers? No, not really. That's not what I wanted. Example using method.axes.plot. No. There's literally nothing that I could do right now. Axes. Box plots by maybe this one? No, because that's not what I want. Matplotlib axes. How to set plt.plot as a subplot. End rows, share x, share y, squeeze subplot kw none. Maybe it's this. Subplot kw dict with words passed dict. So dictionary with keywords passed to the add subplot. Called you to create each subplot so we can. What? Look, it does have it. I'm so confused. Oh no, but oh no, this is subplots, not. Bro, this is so annoying. plt pyplot.axes and make it the current axes. So how do I do this? Is no one gonna say okay plt.axes? What? How does that even make sense? What? plt.axes. So I guess if I do plt, because, but no though, because, oh my god. plt.axes. And then what about figure subplots, pyplot.subplots? Ooh. No, but that still doesn't. What about axes 2 dot plot and then remove this? Fine. Oh my god. Oh my god. Oh my god. I am so thankful right now. Thank you, God. Thank you, God. This is amazing. God is amazing. Wow. Really proud of this. Really super happy about this. Okay, so the problem here that I was trying to solve is if usually, right, when you're trying to make subplots, which is basically multiple plots, multiple graphs, you can think of them. The graphs are also known as axes, or the subplots are known as axes. For some reason, I don't know why, it's so counterintuitive, because you know that axes are your y and x axes in math class, but apparently here, axes, or your ax, are also your graphs themselves. So, they should really rename that. But anyway, you have a figure. Well, first of all, this right here, plt.subplots, creates a figure and creates certain subplots within. So by default, there's only one row and one column, but I specified it to have one row, which is fine. So if I delete that, it wouldn't change anything. But if I delete n columns, which is number of columns, it will change something, and it will just leave me with the first graph over here. So I specified to have 2 columns, meaning I have 2 columns, right? Two graphs here. And then the figure size is basically the size of the figure. So it starts with your x and then your y. So by my x is right 15. So obviously it's larger, and then my y, which is the length of it, is 5, and the x is width, right? And then what this does, it returns to you 2 things. It returns to you a figure with 2 axes. And so let's say you only had, let's say, 1 column, you would then just have ax1. But because you have 2 columns, you want to have it in parentheses and ax2. And I believe if you have 2 rows, then I believe that you have to do 1 parenthesis for all the graphs in that row. So let me actually try and see if I'm correct there. So let me do comma and do ax3, ax4. Not enough values to unpack, expected 3, got 2. What do you mean, where? 2, number of 2 columns, right? So it's 4 plots. So I'll do, just right here, I'll quickly delete this later. I'll do 3, do 4. Not enough values to unpack, expected 3, got 2. Let me see what I have over here in data science, where I had basically multiple right here. Yeah, interesting. Oh yeah, I was right. Only thing is that you have to put, so, oh my god, wait, is it a tuple? It is a tuple. Is it a tuple? Is it really? Or am I going crazy? Is this what a tuple is? A tuple is when you use parentheses and you even have things inside. Is this a tuple of a tuple? I don't even know. Forget I said that. So yeah, it turns out I only forgot one thing, is that they all have to be within 1 parenthesis, so it represents like the entire figure. And so basically for each row you have to label your axes. So if I run this, it should work now, and you should have 4 now, right? So that's the difference. When you have multiple rows, you want to have, well, first of all, in parentheses, you want to have a pair of parentheses for each row, and in each of the parentheses, each of these parentheses, these 2 outside parentheses, represent 1 row. So this is row 1, and it's made up of subplot 1, which is ax1 or graph 1, and ax2, graph 2, subplot 2, whatever you want to call it. And then this is row 2, and in row 2 we have ax3, graph 3, whatever you want to call it, which is the one over here, and then graph 4, x4 or subplot 4 over here. But notice that it's in the same parenthesis, 3 and 4, because they're in the same row. So that's how you would do that for that case. So let me go back and delete. So again, let me do a little recap. So ax1 would be good if this was 1 and this was 1. And then I'm gonna delete these, and it's probably gonna, see, it's gonna just give me 1. And that's all you have to do for 1. But again, if you have And also actually, again, I wanted to show you if you delete n rows, it's going to change nothing because by default, n rows is 1. Only, right? Only if that's your purpose. If you want to have only one graph, obviously you're going to have one row. So it's going to change nothing if I run it, because it's just going to be by default one row. But I always like to have it there so that when I reference the code, I know basically what I'm talking about here. So let me go back and put my code there. What happened? 1 row and columns 2. Oops. And columns 2. Run that. Okay, and my plots should appear. Alright, only thing is, I maybe want a padding of 5 because I feel like they're too close. Okay. Alright. So then okay. Second thing is figure tight layout pad is equal to 5. So we target the figure. So the figure is actually this the entire, like the box. You would think of the box. And in the box there's graphs, which are subplots or axes, whatever you want to call them. So the figure, there's a function called tight layout, and I think it does have other parameters, which I'm not sure of at the moment, but I know one of them is pad, and pad stands for padding, and you set it to a certain number, and that number is used to give space between the two graphs. So if I do like a padding of 50, actually let's do something normal, like 25, it's going to be very spaced. Whoa. What if I do like 1,000? Margins cannot be made large enough. Interesting. So it says that the padding cannot be, oh, interesting. So it's relative to the figure size. So if you set the figure size to be a certain width, right? So if it's 15, the padding won't go but like it won't extend to 15. Like it will respect. I guess it will be by default what it is. So if I put 5 though, you do see more padding in here, but notice that it's within the width that you set for the figure size of 15. Interesting. So that's something new I just learned right now. Okay, line 7. So this is how you start with your plotting your graphs. So sns.histplot, I like to use Seaborn, right? So I plotted the first one, which is the profit distribution, using a histogram, right? So histogram with KDE is equal to true, and then yeah, so I used sns.histplot, and in a histogram, histplot is for histogram, and you know that a histogram it only plots one value, or at least one type of value, and then it counts the frequency of it. So the value that I decided to plot was the profits of the company. And how did I select that? I did data, and then I used bracket notation. I put the name of the column, which is profit, whatever that is, R's, zeros, whatever. And then I said KDE is equal to true because by default KDE is equal to false, and KDE is that curve, that blue curve that you see there on the left graph. And then what I did was in Seaborn, in order for it to show up in your figure, or in order for it to, or that graph to specifically show up in your figure, you have to set x equal to whatever you put here. So if this is x1, then you put x1 here. We could also change this to a different name. It doesn't necessarily have to be x1. We could do figure 1, and then we can change this to figure 1 over here if that makes more sense to you. Or not figure 1, because the figure, I don't want to confuse you, is the actual white box. Graph 1 is the actual subgraphs here. So see, it's the same thing. So you can set the x, which is basically saying, okay, I want the x, I want this here to be plotted on this graph. I want the graph to be equal to graph 1, if that makes more sense. But for now, I'm going to leave it at ax1, so everything is uniform. And then the difference here, instead of doing plt.title, you want to use the methods of the graph. because you're not doing plt.title. Like this is not part of a PLT. This is not part of matplotlib graph. This is now like an actual graph that you set to be AX1. So from AX1 you set the title. That's the same thing as title from plt.title. You do instead AX1.set title, and then you just do the same thing. Profit, distribution, histogram, KDEs, which whatever title you want it to be. So as you can see on the top left corner graph, you see the title. And then my second graph, which is over here, so I'll do second graph, and then this one will be first graph. So the second graph, this was I'm basically tried to do the same things using two different methods. So the first one I did a histogram, and I set KDE is equal to true. But I'm not even sure that these are even the same things. That's why I did a whole research on it real quick. So right now, this is just about learning how to plot these. I'm not even sure that statistically these are the same things. So second graph, X values, I already explained this, right? I did explain this, right? I think I did. Yeah, I did. It's just linspace. You can think of it as a function, right? That takes in 3 parameters. It takes in your starting point, your end point, and how many values you want in between those 2 points. So in math class, if you look, your teacher asked, okay, what's the domain of this graph? So basically, what is that interval, the interval that your graph starts at the x-axis and then ends at the x-axis. So your interval would contain your start point and your end point in the x-axis. So my start point in the x-axis would be my mean minus 3 standard deviations. Well, it would be basically 3 standard deviations away from my mean. So it would be my mean minus 3 times my standard deviations. And then my end point would be my mean plus 3 times my standard deviation, and then I would have 200 values in between. Now the reason I put 200 is because there are 200 rows. There's 200 years of this company's profits. There's 200 instances basically, but I'm not sure if we could get better results if we put something else that other than 200. Okay, Y values. We use stats.norm.pdf, which is the same thing. Well, I think it's the same. It is the same. Well, it's fairly the same. It's the same idea as normal PDF in your calculator, your TI-83 and TI-84, just like stats.norm CDF is the same thing as, not necessarily the same thing, but it's the same like idea as normal CDF in your calculator. So stats.norm.pdf is basically your probability density function, and it's going to calculate the probability density of all of your x values that we assigned here, and taking into account the mean and the standard deviation. Now the mean in this PDF function is known as log, and then scale is known as standard deviation. So now that I think of it, where is my mean and standard deviation? What if I just wanted to run this? Like what? Let me show code over here. Let me get all of this. Okay. All right. What was I doing? Yeah, so if you get confused and you're like, okay, how do I know the difference between log and scale? Well, scale is the only one that starts with S and standard deviation starts with S, so it's the same. And then whatever's left is mean. Okay. And then if you wonder how I get mean and standard deviation, I did explain this earlier, but I just set it to variable. I did data. I targeted the series, the column that I wanted, which is profits, and I got the mean of that column. And then same thing, I got the standard deviation of that column, and I have DDOF is equal to 0. Now, I fear that I didn't explain to you what DDOF is. DDOF stands for degree of freedom. Well, I literally forgot what the other D stands for, whatever. Degree of freedom, and it basically accounts for any bias that can occur when you are basically finding the standard deviation of a sample distribution, or of sample data. But in this case, we consider this population data, so we don't need to account for any bias, because if this is a standard deviation of the population, there shouldn't be any bias, because it should just be the standard deviation of a population. Like, you're not estimating anything as if you would with a sample. So usually with a sample, DDOF is set to 1, and that's what it is by default. And if you use NumPy, actually DDOF is set to 0. So that's the difference. Or just a little fun fact. But here I said DDOF is equal to 0 because I consider this population data, and therefore I don't need to account for any biases that I would get if this were to be sample data. So that's what that is. And then I just did the minimum. So again, I took the column and I applied the minimum function to get the minimum. And then because this is, it's weird because I think it didn't give it to me as an integer, or maybe it did. I just made sure that the data type was an integer by putting this value inside, or applying the int function to that. And I did the same thing over here. I got the column and I got the max of the column, and then made it an integer type, set it as max, and then I used those variables across my my thing. Although I don't think I used min and max for this specific graph. I did use it for version 1 though, so I can delete those. And then finally, we have our axes 2. So again, we have our another graph. So axes 2 dot plot. So here's where the problem came in. I never actually used matplotlib, or actually, I think, interesting, I think this is how I started and I couldn't figure it out, and then I just started using SNS. Seaborn. Wow, do you see the progress? I'm so like, this is an amazing moment for me. Okay, I'm like really happy. So basically, what was I saying? So I always use Seaborn to when I wanted to graph multiple plots, because I did not know how to use matplotlib, as in like the plot function from matplotlib, or actually any function I think from matplotlib, because matplotlib's like plotting functions don't have the ax parameter, therefore I can't set the graph equal to the, how do you say it, I can't set if it were to be plt dot plot like we had it, that was the problem. It doesn't have this parameter, and I couldn't set it to the graph that I wanted it to be, and therefore it wouldn't show up. So that was a huge problem, and turns out that instead of doing plt.plot, ax2 is kind of the replacement or the alternative to that. So I think it does represent plt though. plt.subplots, yeah. So ax2.plot would be the same as plt.plot, except that it literally just that you're basically telling it, hey, I want this to be graph 2. So this is perfect. And then same thing, you set the title, I already explained that. This is concatenation, is that how you pronounce it? Probably. Normal distribution, right, this is the top right title over here in the right graph. I did a mean, and then I added the actual mean because I had it. I just have the mean, and I used the round function, rounded it to 4, and then because this is an integer data type, and you can't use integer data type in string concatenation. Is that how you pronounce it? Like, seriously, I might be embarrassing myself. I basically turned it into a string data type, and I did the same thing for sigma, or for the standard deviation. And then I set the x label, and I set the y label, and then we have these two different graphs. And I think what I want to do is maybe change this to 8. I want it to be more 6. Okay, I think that's better. So now the reason I did this was because I wanted to compare both graphs. So one I did with a histogram. Whoops, I forgot to close that in. And then one I did with, let me actually with norm.pdf, right? Probability density function. What happened? KDE true. Oh, I wanted that inside over here, the quotations. And then space over here, and also parenthesis over here. Okay, run that. Once it stops freezing, that would be great. I can't believe I ate all my candy. I was snacking on my candy. I was eating Starburst and Kisses. Now I need to go shopping for more. I love Kisses. Chocolate kisses are the best. I need to crochet again. 3rd grade class was done with the full rights of college. Wow. Sorry, I'm on Instagram. I'm waiting for this thing to load. Oh, you're joking. If this thing doesn't save, we're gonna have an issue. What happened now? Plus, did I not do plus? I did do plus, so what's the issue? Parenthesis? Yeah, I did. You're joking. Stop. Don't tell me I lost all my work. This is why I have such... I'm gonna cry, actually. I'm not. It's fine. I'll just redo it. Okay, any day now, please. It would be great for this thing to hurry up. Okay, I'll unpause and come back. Oh wow, God is good. He saved my work. Okay. I think everything is the same, right? Okay, perfect. So, yeah, what was I saying? I think I was talking about how, honestly, I don't remember what I was saying. The point of this was to compare these two distributions. One was done with, oh, yep. Okay, that's good. Just have to add this real quick, plus, norm.pdf. This is what I was trying to do. Okay, add that. No, okay, what now? What now, baby? String. This is a string, though. So print for string. Is it not a string? Why is it saying that these things are not strings? Pretty sure this is a string. I'm a little confused. Oh, that's what happened. Oh my god, not again. Please don't crash. Oh my god, I make the same mistake every time. Just put a parenthesis there. And then delete that, and then delete this, and just have a space there. I don't think we need this. Okay, finally. So, one on the left was made with a histogram with KDE is equal to true. KDE is a kernel density estimation, which is that curve that you see, that squiggly curve. And then on the right, we have a normal distribution of the same data, but it is graphed by using normal.pdf, which is calculating the probability density function. And turns out, according to my 5-minute research online, turns out that kernel density estimation is trying to estimate the probability density function. So then why is it called kernel density density? You know what? Okay, but yeah, turns out KDE tries to kind of estimate the probability density function. So why do we need to estimate the probability density function if we just can do the probability density function? Am I missing something? I don't know. This is like stat knowledge now. Like, I'm trying to really understand this right now. Like, what's the difference between these two graphs, and why do we need KDE? What's the purpose of it? Like, when do we not have the data to do norm.pdf? Is there possible to do KDE without the data? That doesn't make sense. Because it makes sense that kernel density estimation is used to estimate probability density function, because you can clearly see that it's almost kind of normal, even though it's kind of a little squiggly at the right, on the left graph. But I don't know. And you know, I find it interesting that, it's not interesting, but it's like a known fact that all normal distributions look the same. Only thing different is just the axes. And by axes, I don't mean x as in graphs. I mean the literal y and x axes. You can see the numbers are different. Even for like different times I've done this, it's different. It's just interesting. Like, it really is interesting. It's so interesting. And I also want to know if I messed up, if, for example, if I go back up to this number over here for 200, this is the parameter which tells how many values are in between your x start point and your x end point, which is, you know, these two values in here. So again, in the graph, your x start end point is negative 500, and then it's like around negative 500, and then over here it's 2500, around there, right? But then in between those we have 200 values. The question is, are those 200 values? No, this doesn't make sense, because this is a year. Hold on, no. Actually, yes. Oh no, this is perfect. Yeah, no, yeah. I was thinking, yeah, never mind. I plotted the profit function, which is continuous data, right, not discrete. So if I were, is it taking the 200, it's just going to take 200 random ones. It's not going to take, like, look, you can even see it. I'll show you right now. Look, like if I do this and I do code and I run this, it's going to give me an array, and it's going to show me the numbers that it's calculating the value for. But are those numbers the same numbers in the profit column, in the profit series? So is it calculated? Does it even matter? Does it even matter if it's calculating those values or not? Because these are not, I mean, I'm sure that all of these 200 numbers are not exactly the profit. This is so interesting. It's not exactly the profit of, wait, why is it -4? What? It's not exactly all of the profits. Like, for it doesn't freeze again. Oh my god. Oh my god. Oh my god, maybe this is a sign to go to sleep. I still have 2 things to do. I have web development and Blender. I wonder what I'm going to do for Blender today. I think I'm just going to make a desk because, or a table. No, a water bottle. I love bottles. If you could tell, all my videos are bottles. I like practicing them. They're really good for practicing loop cuts, by the way. Here I am trying to make conversation while this thing takes 5 hours. Oh my god. Okay, I'm just gonna go on Instagram while this loads. And I'll probably do you a favor and just come back. Okay, we're back. Where was I? No way, it did the same thing again. It's not saving. Ugh, okay, let me do this again. Go over here, plus norm.pdf, and then run it. Hopefully I didn't mess up. Okay, great. Now, I was going to show you what the PDF values, not the PDF, excuse me, the profit values were. Here, you can see, right? You have a profit of $16.45, $558, $19.26, $865, and if you go to the actual linspace of the actual values that we're calculating, oh my god, if this thing freezes again, it's over. It's literally over. Like, I'm gonna shut this down. I'm gonna be like, goodbye. Okay, great. It's gonna freeze again. Alright, where was I? I don't even know where I was. Over here. This over here. Take this. Whoop, shouldn't have done that. Should just do this. So see, you don't have 685, whatever the number was, or 16, whatever number was. We just have, I don't know, like, these are not the values of the profit, and should they be, or does it matter? Does it matter if it's 200 random profits? Should they be 200 random profits, or should they be the values that are in the profit? And if so, then how do I make sure that the values that are in the profit minus the mean, the endpoints are calculated within those endpoints? Like, is that even a question? Like, that's what I'm trying to get at here. If I go back, that's what I'm trying to see over here, right? See those differences. If I look at data.head, I could actually just do data profit rs just oops, why doesn't it? Interesting. Why is it like that? I think I can't do it that way. Hold on, let me do data. Yep, like that. Ew. Why is it like that? I don't want it like that. How do I change it? I forgot. How do I do this? That's like really ugly. How do I change it? I forgot. Data. Whatever, I don't care. But here it's kind of even more clear. You have 1645, 658, 1926. And then if you, why am I here? This is supposed to go back down there. Right. Go here, run that. 1645, 658. And why does it keep doing that? Is this thing going absolutely crazy? Like, it's so annoying. I'm literally telling you to go here. 1645, 658, and then all these numbers you see here are just like 1.99, 1.98. Like, what? 0, 3? 3, 4, 5. See, it's like, does it matter that it's just 200 random variables, or do I have to put in, like, I want those values? Like, is this even possible? Like, this is what I'm really trying to get at, but I don't think that's even possible, because I tried it at the beginning and it didn't give me the work. So that's a question to kind of question, if that makes sense. So I think that's what I'm gonna end up today. I mean, I didn't say in the beginning of the video the purpose was to explore the difference between PDF and CDF, but you know what? It's okay. We can spend a week on this or whatever. I don't know. But I did get up to making the histogram, which is fine, perfectly handy, dandy, whatever. It's fine. And I really enjoyed, plotting. We learned, I reviewed some skills that I had learned. I learned some new things. I applied some new things. I figured out a whole new thing, which is really exciting. And I think I really want to copy this. This is what gave me, I think over here, AXT, over here, yeah, it gave me this. This is what kind of, oh, okay. I guess I'll just do this here. Can I do copy link? Nope, I guess not. I'll just do this. But this is what gave it away for me. Really, really great. So I'm just gonna copy that resource into here. Right. And then what else? Yeah, so we kind of discussed, well, I discussed by myself, like I discussed basically, not really, I kind of explored. I didn't discuss. It's not like I'd learned, like I knew this before. I was learning as we went, but I explored the difference between kernel density estimations versus probability density functions. I explored the differences between how to make both of them visually. I explored how to graph subplots using matplotlib plot functions, including Seaborn functions. I reviewed some plotting skills, like if we had multiple rows, how to call axes, which is really great. There was a question that came up with how to, whether or not to, like, it doesn't matter if I use 200 random variables, or do I have to use the 200 profits that were given to me. Does that affect the distribution of the data? I mean, I don't think so. Either way, it's a distribution, even if whatever. But that's one question to think about. And then I guess we'll continue this research tomorrow, and eventually we'll get to actually exploring the difference between PDF and CDF, given this data, and see what those differences are. But currently, I kind of just focus on the differences between KDE and normal PDF, which I think is fine. I think it's fine to understand the basics first and then keep on going. Like if something comes across as new, then I feel like it's fine to dive deep into that before you keep on going. So that's what I did. And I'm just going to go ahead and copy this and just delete it and just put this over here. If I do print over here and print this, well, this one will do it anyway. And I do that. Yeah, I will do it. Okay, perfect. So I'm just gonna go right click, add a form, and call this do values in between interval matter between x interval x values, whatever. You get the point. So that's one thing. I'm gonna leave that there. I think that's what we're gonna do for today. Today was really a good day. Version 1, blah blah blah. Let's go back. Okay. All right. Bye.